Engineering and Technology. So today we are going to study few more topics of applications of integration. So let's begin with the first topic, that is volume by slicing. We will study the method of slicing to find the volume of solid whose cross sections are plane regions. This method is based on the formula volume is equals to area into height. By this method, the volume of solid of known cross-sectional area A of x from x is equal to A to x is equals to B is given by V is equal to integration A to B A of x dx, where Ax is integrable. Okay, so this is the formula to find the volume of a solid of known cross-sectional area A of x from x is equal to A to x is equals to B. Now, the volume of a solid of known cross-sectional area B of y from y is equal to C to y is equal to D is given by V is equal to integration C to D B of y dy, where B of y is integrable. Okay, so this is the formula to find volume of a solid of a known cross-sectional area By from C to D. Okay, now let's solve one example. Find the volume of a cone with height 4 cm and radius of base 4 cm. We will use this method of slicing. Okay, so let's begin with the solution. Let us consider that the cone is centered at the origin with its axis as the x-axis. Okay, so the cone is centered at origin and it is axis at x-axis. This is your x-axis, right? Now, this figure shows that the cone with the height 4 cm and the radius of the base is also 4 cm, right? Now, if you will consider this one slice, so this is a circle. So, if you will make these slices, it will become a circle only, right? So, the cross-sectional area at x is what? Is A of x is equals to pi x square. We know the area of circle is what? Pi r square, where r is the radius. But we are considering it on the x-axis. Therefore, we will write A of x is equals to pi x square. Okay. Now, the required volume is V is equal to integration A to B A of x dx. Okay. Now, Ax is what? Pi x squared substituted. Right. Now, take pi outside the integration and integrate it. So, you will get x cube upon 3 and the limits are 0 to 4. Okay. Substitute the limit. In place of x, we have to substitute 4. So, you will get here 64 by 3 minus 0. Okay. Simplify. So, you will get answer as V is equals to 64 pi upon 3 centimeter cube. Okay. Now, let's begin with the new topic, that is volume of a solid of revolution using cylindrical disc method. The solid of revolution is generated when we revolve a plane region R about a line L. The line L is called axis of revolution. Okay, now we will study the revolution about x-axis. Now, when the area bounded by the curve y is equals to f of x, the coordinates x is equal to A, x is equal to B and x-axis is revolved about x-axis. Then the volume of a solid generated is given by V is equals to pi integration A to B y square dx. Okay, so this is the formula to find the volume when it is rotated about x-axis. Okay, now we will study the revolution about y-axis. Okay, so when the area bounded by the curve x is equals to g of y, the y is equals to c, y is equal to d and y-axis is revolved about y-axis, then the volume of a solid generated is given by V is equals to pi integration c to d x square dy. Okay, so we will use this formula to find the volume when it is revolved around y-axis. Okay, now the volume of a solid generated by revolution of area about any axis. So, when some area is revolved about any axis, then the volume of the solid generated is given by V is equals to pi integration A to B r square dh, where this r is perpendicular distance from the curve to the axis of revolution. So we will use this formula to find the volume of a solid generated by revolution around any axis. Okay, now let's begin with the example. The region between the curve y is equals to under root x and x is between 0 to 4 and the x-axis is revolved about x-axis to generate a solid. Okay, and we have to find its volume. So let's begin with the solution. Now the area bounded by y is equal to root x, okay, and x is between 0 to 4 and the x-axis with the revolution about x-axis is shown in the figure. Okay, so this is shown, that is y is equal to under root x, that is y square is equals to x. So this is a parabola about x-axis, okay, and the limit of x is given, that is x is from 0 to 4, and what we are doing, we are revolving it around x-axis. So you will get this type of solid on revolving around x-axis, correct? Now we will find the volume. Okay, so it is given by the formula v is equals to pi integration a to b y square dx. Okay, now the limits of x is what, 0 to 4. So here we have pi integration 0 to 4 y square dx, right? Now we know y is equal to under root x, right? So y square is equals to x. So we have v is equals to pi integration 0 to 4 x dx. Integrate it, so you will get x square by 2, right? And the limits are 0 to 4. Substitute the limit, so you will get pi into 8 minus 0. Simplify, so you will get the answer of volume as 8 pi. Okay, now we will discuss one more method, that is volume of solid generated by two intersecting curves, that is the Washer's method. Okay, so suppose A be the area bounded by two curves y is equals to f1 of x and y2 is equals to f2 of x. Let x is equals to a and x is equals to b be x coordinates of their point of intersection. Okay, then the volume of a solid generated by revolution of area A about x-axis between the coordinates x is equal to a and x is equals to b is given by v is equals to pi integration a to b y2 square minus y1 square dx. Okay, provided f2 of x should be greater or equal to f1 of x. Okay, so whenever we have this type of condition that f2 of x is greater or equals to f2 x, we will use this formula to find the volume. Okay, now let's begin with the example. The region enclosed by the parabola y is equals to x square plus 1 and the straight line y is equals to 2x plus 1 is revolved about x-axis. Okay, so we have two curves, one is parabola and another is line, and it is revolved around x-axis. Okay, and we have to find the volume of solid of revolution. So let's begin with the solution. Now, firstly we will find the intersection point. Okay, so the curve are given, that is y is equal to x square plus 1 and y is equals to 2x plus 1. So we will compare them. So x square plus 1 is equal to 2x plus 1. This one will get cancelled. So, and bring this 2x over here. So you will get x square minus 2x equal to 0. Take out x common. So x into x minus 2 is equal to 0, right? So from this you will get the answer of x as 0 and 2, right? Now for x is equals to 0, substitute over here. So you will get y is equals to 1 and for x is equals to 2 here. So you will get y is equals to 5, right? So the intersection points are what? From here 0, 1 and the another intersection point is 2, 5. Okay, now the volume V generated by revolving the area between y is equals to x square plus 1 and y is equal to 2x plus 1 about x-axis is shown in the figure. Okay, so here it is, this is the line y is equals to 2x plus 1, right? And this is the parabola y is equals to x square plus 1. The intersection points are 0, 1 and 2, 5. Okay, and we are revolving this about x-axis. So you will get this type of solid. Okay, so we have to find its volume. So volume is given by v is equals to pi integration a to b y2 square minus y1 square dx. Okay, now x varies from 0 to 2. So we have pi integration 0 to 2 y2 square minus y1 square dx. Okay, now substitute the value of y2 and y1. Okay, Now we have line before, so we will write here 2x plus 1 whole square in place of y2, and in place of y1 we will write the parabola, that is x square plus 1 square. Then okay, now simplify this. You will get pi integration 0 to 2 2x plus 1 whole square minus expand this, so you will get x raised to 4 plus 2x square plus 1 dx, right? Now we will integrate. So on integrating you will get 2x plus 1 raised to 3 upon 6. We have 3 and this 2 we will divide it by 2, so you will get 6 over here, right? Minus integration of x raised to 4 is x raised to 5 upon 5 minus here integration of x square is x cube upon 3 and integration of 1 is x. Okay, now we have to substitute the limit. So you will get 104 upon 15 pi, right? So this is the volume when we have revolved around x-axis. Okay, now let's discuss one more method, that is cylindrical shell method. This method is used when the axis of rotation is not a part of the boundary of the plane area A. If the area is rotated about y-axis, then v is equal to integration a to b 2 pi x into y dx, and if the area is rotated about x-axis, then v is equal to integration c to d 2 pi y into x dy. Okay, now we will solve one example. Find the volume generated by revolving the area bounded by 2y is equal to x square, x is equal to 4 and y is equal to 0 about y-axis. Okay, so let's begin with the solution. Now we are given 2y is equals to x square. Okay, so in place of x just substitute 4, so you will get 60, right? So you will get the value of y as 8. Okay, now for y is equals to 0, if you will take y is equals to 0, substitute over here, so you will get x is equal to 0. Okay, so you will get the intersection point as 0, 0 from this, and here x is 4 and we have y 8, so the another point is what, 4, 8. So intersection points are 0, 0 and 4, 8. Okay, now the volume V generated by revolving the area bounded by 2y is equal to x square, x is equal to 4, y is equals to 0 about y-axis is shown in the figure. Okay, so here this is shown that is 2y is equal to x square. Okay, this is the line, x is equals to 4 and the intersection points are 0, 0 and 4, 8. Okay, we have to revolve this around the y-axis, so you will get this type of solid, right? So the required volume V is given by V is equal to integration a to b 2 pi x into y dx, right? Now we know y is what, x square upon 2 from this, right? So in place of y just substitute x square upon 2, simplify this, so you will get pi integration 0 to 4, take out this pi common, 2 will get cancelled, this is x cube. Okay, now we will integrate it, so you will get x raised to 4 upon 4 and the limits are 0 to 4. Substitute the limit and simplify, so you will get the answer of volume as 64 pi. Okay, so I hope you have understood throughout the session. Thank you for watching.